Assalamu alaikum. Hello, everyone. I'm Dr. Zahur Islam, and you are watching me on my YouTube channel. So you can see here on my screen coacervations. As we know that this is another method which is used for the preparations of nanospheres from the preforms polymers. So what is coacervation technique? So coacervation is the phase separation technique, and this technique was for the first time introduced by the scientists Bungenberg, de Jongs, and Reut, who describe a process in which the aqueous colloidal solutions they are separated into two liquid phases. One is the colloidal rich phase or coacervate, and the colloidal poor phase. Many synthetic polymers they are water insoluble, and consequently non-aqueous coacervation system have been employed. So coacervation usually consists of binary and ternary system. And binary system as usually so it consists of one polymer which can be dissolved in a solvent at the ternary system of either a single polymer in a binary solvent mixture or two polymers in a single solvent. So for binary system, the phase separation can be occur by changing the temperature or pH by the addition of electrolytes such as sodium sulfate to gelatins. For ternary systems, the phase separation can be induced by adding a non-solvent for a single polymer system or by adding a polymer incompatibles with the second polymer for a two-polymer system. Solidification of the particles produced by coacervation can be affected by temperature, chemical cross-linking, and adjustment of pH or rinsing with a non-solvent for the polymer. The coacervation process is a control which is controlled by the interaction between the polymer, solvent, and non-solvent. The formation of the stable coacervates is influenced by the polymer type in the molecular weight and the hydrophobicity, and by the amount, the quantity, and the viscosity of the added coacervating agents. By careful adjustment of these parameters, so optimum coacervation condition can be achieved by the use of phase diagram. So the classical coacervation methods for the non-aqueous system has been modified to produce nanoparticle by using an emulsion phase separation methods and aisle system. An aqueous solution of the drug, a peptide in this instance, was emulsified in dichloromethane DCM acetone mixtures containing the dissolved PLGA using homogenizations. Triester oil or caprylate and caprate triglyceride was added gradually, inducing the phase separation of the PLGA. At the interface between the aqueous and oily phase, the aqueous droplets they are covered with the coacervate droplets of PLGA, and the evaporations of the organic solvents reduce the solubility of PLGA and deposit it around the aqueous droplets containing the drug. And this mechanism is already shown in the figure 8. So, as I'm discussing about the methods through which we can formulate and we can prepare the nanosphere. So, why I'm repeating the PLGA, which is also called polylactic glycolic acids. You know, this is one of the most effective biodegradable polymers, polymeric nanoparticles, and it was for the first time it was approved by the US and FDA by using the drug delivery system due to control and sustained release, low toxicity, and biocompatibility with tissues and cells. You can see on my screen that nanoparticles they are encapsulating the 5-fluorouracils, which were prepared by coacervation using cellulose derivatives. An ethanolic solution of ethyl cellulose was desalvated by stirring in the distilled water, which producing the particles with an average diameter of 470 nanometer, as determined using the scanning electron microscopes. This is what scanning electron microscope. This is the method you can see here in figure number 8. How the coacervation processes take place. So this one is what? This one is water and oil type of emulsion by the addition of triester. So here the coacervate, the deposited droplets, they are coacervates. And after that there is occur evaporation of organic solvents and nanospheres are formed. This one is aqueous phase and this is organic phase. So how the coacervation will be occurs, so you can see here there is clear the formation of the nanospheres, and these nanospheres they are formed by the coacervation process, and with the organic phase and aqueous phase you can say there is a proper boundary, and this one is so the water and oil type of emulsion. So by the addition of the triester, so there will be the deposition of the droplets by coacervates and the evaporation of organic solvents occur and nanospheres are formed. This is the preparation mechanism of PLGA nanospheres by emulsion phase separation methods in an oil system. So as I was talking about the electron scanning microscopy, so the nanospheres of the methyl cellulose were prepared by desolvating an aqueous solution of the polymer with sodium sulfate solution. So an average particle size of 540 nanometer was obtained. The main drawback to coacervation method is the toxicological implication of the residual solvents, coacervating agents, and hardening agents left in the particles. More biocompatible coacervating and hardening agents are being investigated, along with the approach to minimize the solvent residues. The triester oil used in coacervation of PLGA by NIVA, etc. So, which is very non-toxic and biocompatible, and an alternative to the silicones oil. This is used in coacervation of PLG, and biocompatible hardening agents suggested includes the fatty acid ester, such as isopropyl myristates for the PLGA. So, for low molecular weight polymers, the drying near the glass transition temperature of the polymer was found to be effective and lowering DCM content. So inshallah in my next lecture we will discuss about the nanoparticle productions by using the supercritical fluids. So this is another very interesting topic. So inshallah we will talk about all these nanoparticle, how the nanoparticle they are produced by using the supercritical fluid. So thank you so much for watching my lecture. So if you didn't subscribe my channel, so please subscribe it and click on the bell icons for my upcoming lecture. Thank you so much.